Alright, so for this video what we're going to do is we're going to be going over nomenclature. And so nomenclature is pretty much just naming of compounds. It's just a fancy name for naming. And the rules that dictate how we name an organic substance are kind of determined by the International Union of Pure and Applied Chemists, and that's abbreviated IUPAC, IUPAC. So if you see that, that is what that means, and that's basically an organization or a group that gets together and decides how we should name organic substances. And this is really important, so that way we as chemists can communicate clearly and in a concise manner. So if I name a substance in the US, that people in Europe are going to be able to understand that because they also follow IUPAC rules. Okay, so again, it's an international union, and so every country follows these rules, and that allows us to communicate very clearly. Okay, and so part of the rules include this basic order of naming a substance, and so we have a prefix, and that's basically going to be what and where the substituents are on a given substance, or like where the things are attached. Okay, and then that after the prefix we have the parent chain. And so what is the parent chain? It is the longest carbon chain in that particular substance. And then lastly we finish it off with the suffix. And what is the suffix? It is basically the functional group, and so different functional groups have different endings or suffixes. And as we remember from a previous video, hopefully, the suffix for alkanes is -ane. Okay, and so going just as a little reminder, we have our number of carbons as well as our prefixes here. And so numbering our carbons, or having 1 up to 10 carbons, we were given prefixes meth, eth, prop, bu, pent, hex, hept, oct, non, and dec. Okay, and so if the number of carbons in this group is basically the parent chain, then we would put the prefix of that set of number of carbons and then finish it off with -ane. Okay, and that's basically how we would name an alkane. Okay, so for example, we have 1, 2, 3, 4, 5 carbons in this particular example, and so that brings us here. So we want to go ahead and put the pent as our prefix, and since it is an alkane, we can place the -ane at the end. Okay, and so this is basically the parent chain, and this is the suffix, applying it to this formula up above. Prefix doesn't apply here because if you read the definition of the prefix, it says what and where the substituents are. Okay, and so we don't have any substituents on this particular example, but let's take a look at this one. So 1, 2, 3, 4, 5, but then something's coming off here. Okay, so technically this does have 1, 2, 3, 4, 5, 6 carbons, right? And you might feel inclined to just say 6 has a prefix for hex and then call this hexane, right? If you did that, that would be incorrect, because hexane is this structure, right? 1, 2, 3, 4, 5, 6 carbons, and this is in fact hexane. Okay, so what the heck is this thing up here? Well, remember the rule is basically we'll go over the rules, but the this group right here, since it's kind of dangling off the major portion of the carbon skeleton, if you will, that is called a substituent. Okay, so as a substituent, we want to end basically add the prefix and then finish it off with a different ending. Rather than -ane, we end it in -il. Okay, and so for example, this particular substituent has only 1 carbon, and therefore it has the meth prefix. Okay, and then since it is a substituent, we want to finish that off with -il. Okay, And so more specifically, we can go ahead and write down the actual IUPAC name, and this would be 3-methyl-pentane. Okay, and without going over the rules, we can see that there is a prefix here, that 3, and it's telling us, hey, it's what and where the substituent is. So this 3 indicates that it's on the 1, 2, 3, third carbon, and it is a methyl, so what and where. And then pentane is basically the parent chain followed by that suffix. Okay, and so this is an example of naming an alkane following the IUPAC rules. Okay, and this structure is going to be 3-methylpentane in the US, in Europe, in Australia, in China, no matter what. It's going to be that, and it's going to be well understood, and that way we don't have any issues, right? So let's go over some common substituents, and then we can go over the rules for naming organic substances. Okay, and so what I've done here is I have labeled, at least up here, I have a black carbon chain and then the blue substituents coming off of it. So let me just finish. Let me do this. I'm going to put an R group here because that would be more appropriate. Okay, because we don't know what's going on the rest of that molecule. All we know is that we have these blue substituents coming off. These are actually some really common groups that you'll see throughout organic chemistry, but we don't usually call them by their IUPAC name, and they're just called basically, or they're named based off of their common name. And so that's why we want to make sure that we're aware of this, because you technically can call them or name them based off of the IUPAC name, but it's just much easier to name their common name. Okay, so this group right here is called isopropyl. Okay, this group right here is just a propyl group. And so obviously that propyl group, that follows the IUPAC rules, but I just wanted that there so that way we could differentiate between the propyl as well as the isopropyl group. Notice the bond connectivity is different. Here we are bound to this second carbon, or this secondary carbon, and we have a group coming off to the left and the right. And whereas the propyl group is bound to that terminal carbon, and it's just kind of a straight chain coming right off. Okay. Now we also have this particular group right here, which is called a sec-butyl group. So sec-butyl, butyl because it has 1, 2, 3, 4 carbons, and sec because if we're looking at just the substituent, so just this portion right here, this carbon is a secondary carbon. So if you, let's just say we were looking at butyl or butane, for example, this carbon is a secondary carbon, and that is why it's called sec-butyl, because the sec stands for secondary. And I notice I also wrote sec in lowercase letters, and that's because I don't know how to draw in italics. If you do, then you fancy. But if you ever see it in print, you'll notice that sec, as well as this guy right here, tert, butyl, are always going to be in italics. They're going to be italicized because of a distinction that we want to make very clear. So the sec, first of all, again, is because that carbon in just butane is a secondary carbon, whereas this guy right here, if you wanted to think of it like that, that is a tertiary carbon. So that's why that's called tert. The tert stands for tertiary. Okay, and back to the distinction. These are italicized because sec and tert are not used in alphabetizing for naming of substances. Oh, not used in, I don't know how to write, so alphabetizing, okay, for naming. So you don't need to know what that means necessarily, but at least now we'll go over the rules in just a second. But we know how to alphabetize things, right? So if we wanted to put things in alphabetical order, we have this propyl group, we have an isopropyl group. Comparing these two, I comes before P, and so we would put isopropyl first and then propyl. But if you look over here, we have a sec-butyl and a tert-butyl. Both of these will be classified as B. So we would put them before isopropyl as well as propyl because of this rule right here. Sec and tert are not used in alphabetizing for naming. So therefore we just use the B in each of these. Okay? And again, we'll see what more about naming in just a minute, but let me give you a couple other groups. This also has 4 carbons, so it is a butyl group, but notice the bond connectivity is different than the other two. And it also looks very similar to the isopropyl group in this portion, and it is actually called isobutyl. Okay. Now, we've got another one, or 3 other ones that are pretty common. These ones are a little bit less common, but nevertheless we want to go over them. So these do look pretty similar to the ones above, but there's actually 5 carbons in each of these, so 5 C's. And this one is isopentyl. You probably could have guessed that by the looks of that. This one right here, what do you think that is? Ooh, that's a tertiary carbon, I'm sorry. It is a quaternary carbon, and it's this one is a little unique. It's not kind of as you would suspect because we haven't seen it before. So this is like the matrix, neopentyl. And then this one, this is actually what I meant to suggest a minute ago when I was pointing at that carbon. This, if we're focusing on just that particular substituent right there, that carbon is bound to 1, 2, 3 carbons. It's almost like this one right here, where it was tertiary as all by itself. And this is called a tert-pentyl. Okay. All right, so these are some common names, and these are actually okay to use even though they're not necessarily following the IUPAC rules, okay? So I love using isopropyl or isobutyl rather than kind of breaking down that substituent according to the IUPAC rules, okay? But speaking of IUPAC rules, let's go over the first one. Rule number 1, find the longest chain. So if there are 2 chain options as the parent chain, you want to choose the one with the most branch points. So what do we mean by that? Well, let's take a look. We've got a structure here, and what we want to do is try and figure out where the longest chain is. You might feel inclined to just go straight from left to right, but don't. That might work a lot of the time, but structures are intentionally drawn kind of differently, so that way it forces us to look more clearly. So let's take a look. We've got 1, 2, 3, 4, 5, 6. Okay, that is 6 carbons, and let's see if we can find another one that might be longer. We've got 1, 2, 3, 4. Whoops, my darn thing got all messed up. 1, 2, 3, 4, 5, 6. There's another one. We've also got 1, 2, 3. Oh my goodness. That is getting annoying. I'm sorry about that. 1, 2, 3, 4, 5, 6. Okay. Now notice the green one only has one substituent. That would be this isopropyl group coming off, right? Whereas the red one, for example, has this one coming off as well as that one. So there's two substituents coming off. And then the blue one also has this substituent and this substituent. Now, it might be hard to notice at first, but the blue and the red are actually equivalent because after we name it, or once we learn how to name it, it'll be easier to explain, but they would basically have the same name. Okay, so I'm going to go ahead and stick with the red, okay, as our longest parent chain. And it is the longest parent chain with the most branch points. So choose red. I'm only choosing red just because it's aesthetically pleasing and it goes straight across. I could have chosen blue as well, but definitely not green. Okay, so for the next one we have the second rule is numbering. So with a little side note, substituent has to have the lowest number possible. Okay, so what that means is, first and foremost, what we want to do is look for the longest chain. Okay, and let's see, obviously, or let's just start over here. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7. Now we can go either way. Notice that this is 2 carbons and this is 2 carbons, so it doesn't really matter which way we go, but I want to go this way for some reason. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9. Did I count that right? Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9 carbons. Okay, so the other route would have been good to go as well. This route, it would have been 9 carbons too, but I chose this route. Okay, so now what do we mean by numbering? What it means is we can number from left to right or from right to left. So we can label this one as carbon number 1, or we can name this one as carbon number 1. And the way we want to do that is by making sure that our substituents, like this ethyl group here, this methyl group here, and this methyl group here, have the lowest number possible. Okay, lowest number possible. And so what that means is if I labeled 1, 2, 3, 4, 5, 6, then that would give me, actually, let me finish writing it. So 7, 8, 9. Okay, now I'll label from the other direction, but I'll label it in blue. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9. Now notice when we're labeling from the label in red, the first substituent is actually showing up at 3. And if we're labeling in blue, we also have the first substituent at 3. Okay, so what the heck, which one do we do? Well, if they are equidistant, then the number, what we want to do is number such that the second substituent gets the lowest number. Okay, if equidistant, number such that the second substituent gets the lowest number. Okay, so what do we mean by that? Well, if we look at the blue labeling, the next substituent is at carbon number 4, and if we look at the red labeling, the next substituent is at carbon number 6. So what we want to do is choose the blue numbering, because it gives us the number, the lowest number possible for the first and the second substituent. Okay. And so this is going to be something pretty common, I think, that you're going to come across because it's a great question. It requires you to know the rules pretty well, and so put that into your brain. Flashcards might actually be really good for this. I don't typically suggest flashcards for a lot of things in organic chemistry, but definitely when you're like kind of trying to remember these rules. So anytime you have vocabulary or anything like that, so it's always good to do flashcards, I think. So name and number substituent. So name and number substituent. Okay, and we want to do that. Let's see. Let's do that for the above compound. So above compound, just so you're clear on what we're numbering or naming. So let me draw that again though. So let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, and we ended up going with blue, which started here. 1, 2, 3, 4, 5, 6, 7, 8, 9. So what we want to do is write down those names. Okay, so first it's not 9 carbons, and so if we go look back at our chart here, the number of carbons for 9 is got the prefix non, and since it is an alkane, that's the functional group. Basically, we will write non-ane. Okay, and that takes care of at least this portion. But now we have those now we have those substituents that we want to focus on. 1, 2, 3 different substituents. So this particular rule is name and number the substituents. And so what we're going to do is at carbon number 3, we have 3, and then we're going to put a dash, and then that has 2 carbons in it. Okay, and if you're not familiar with what 2 carbons is, it is F. Since it is a substituent, we want to finish that off with a YL. Okay, so 3 ethyl. This is at carbon number 4, we have 1 carbon, so that's meth, and then again it's a substituent, so that's ending in YL. We also have a methyl group at 7 as well. Okay, so these are the name and number of all of the substituents. Okay, and one thing I want to mention is anytime anytime you have multiple substituents that are basically the same thing. So what I mean by that is here we have 2 methyls. What we want to do is actually combine these and call them 4, 7 dimethyl. Okay, and so this brings me to another point. Notice the numbers are separated by a comma, and then the numbers and the letters are separated by a dash. And so this is the general convention. Numbers are separated by comma, and letters and numbers are separated by a dash. Okay, so now what we want to do is combine all of those substituents as well as the name of the parent chain, and then go ahead and finish that name. So that's the 4th rule: combine all to name. Whoa. To name. Whoa. I'm tripping. I'm sorry. Combine all to name compound. I don't know. Let's just shorten it. Okay. All right. And so what we want to make sure that we're doing is putting the substituents in alphabetical order. So substituents in ABC order. Okay. Remember that sec and tert don't count for alphabetical order. We also don't count the di or try, etc. I'm putting etc. because if we have 4, it's tetra, and so we could have more than just 3 of the same substituent, and we'll put a prefix in front of that. But if we do have a di or a try, for example, then we don't alphabetize it according to D or T. Okay, so those don't count either. So technically the 4,7 dimethyl would be under M as in Mary, or Miles, my son. Okay, and so what that means is in order to name the above compound, we have 3-ethyl, we also have a 4-methyl and a 7-methyl. Okay, and so E comes before M. Okay, this is a perfect example because we were pointing out that D is not used to classify or categorize for alphabetical order. So we have 3-ethyl, and then remember the letters are separated by the numbers with a dash, and then 4,7 dimethyl, and then we finish it with our parent chain and then our suffix at the end. So the name of that compound, this compound here, is 3-ethyl 4,7 dimethyl nonane. And again, that's no matter where you are in the world. Another thing we want to mention is that if we have a branch substituent, the way we name that is as a compound, and then we can include the prefix in ABC order. And so let me write that down for you. So if it's a branched substituent, whoa, did you see that magic? It just disappeared. All right, if it's a branch substituent, then it is named as a compound, and we include the prefix in ABC order. Okay, so here's an example for you. Let me draw this. 1, 2, 3, 4, 5. We'll just give that an R group and then another R group. Let's say we have 1, 2, 3. That's coming off, and then that's coming off, and then that's coming off. That looks crazy, right? How do we name that? Well, this is a branched substituent. Okay, and so what we want to do is name it as a compound first. And so the way we would number coming off of this is 1, 2, 3, right? Because that's pretty much what is coming directly off of that parent chain, and so that is a propyl group. Since it is a substituent, it is a propyl. Okay. Now on that carbon number 1, 2, 3, on carbon number 1, what do we have there? Well, we have a methyl group, right? That is on carbon number 1, and then on carbon number 2, we have a methyl group as well. Okay, so if we were going to name this particular compound by itself, we would say it's a 1, 2, separating those numbers with a comma, and then a dash separating the number from the letter with a dash. And since there's 2 of the same, we do dimethyl propyl. Okay, and this is our the name of our substituent. And if we read above, so that we branch substituent, we name it as a compound, and then we also include the prefix in ABC order. So that means now we would actually include that dimethylpropyl. Okay, and so this would be in parentheses, and that would be our substituent. So let's say this was carbon number 1 and this was carbon number 2. We would have a 2 there to represent the substituent coming off. Okay, and a scenario where we have 2 of the same thing on a parent chain, on a given carbon. Okay, so 1, 2, 3, 4, 5. Let's just do 6 because why not? I like 6. But then let's say we have a substituent. Well, we've got a methyl group there, and we've also got 2 methyl groups there. Okay, let me make sure I didn't ruin the naming of this real quick. So we've got 1, 2, 3, 4, 5, 6. Remember, that's hex. And it's an alkane, so we finished that off with ane. We've also got a substituent here, here, and here. So let's go ahead and number from the left side. 1, 2, 3, 4, 5, 6, because that gives us the lowest number for the substituent. That's a 2. That's the lowest number for the first substituent also. So it's 2 methyl. And then at the 3 position we have a methyl. And then at the 3 position we also have another methyl. Okay, and what the point that I wanted to make here is that we don't just say 3-dimethyl it's important that we indicate there are 2 methyls on that 3, and the way we do that is by saying we have a 3, 3. And so obviously we still have that other one at the 2 position, so it'd be 2, 3, 3, and then we would finish that off with a trimethyl, and then hexane. Okay, and so this is all one word as well. I want to make sure you understand that. It's just, that looks like kind of like a space right there, but that's just the way I drew it. So it is 2,3,3-trimethylhexane. This might seem kind of redundant, but it's actually really important to make sure that we are aware that there are 2 methyls on that 3 position. Okay. Now, the last thing we want to do for the nomenclature is naming cycloalkanes. And then maybe we can get some practice in, huh? You want to talk about practice? All right. So basically, it's the same as above, but the ring must be bigger than the straight chain to be considered the parent chain. Okay, so let me write that down for you. So it's the same rules as above, but the ring or the cycloalkane must be bigger than the straight chain to be considered the parent. Okay, so what I mean by that is, let's say we had this. Okay, well, let's count it out. So this guy right here, this ring, it's only 4 carbons, right? I'm sorry, it's only 3 carbons, but this particular group right here is 1, 2, 3, 4. Okay, so since that is 4 carbons, and this one's only 3 carbons. This one is technically the parent chain. Okay, and so we wouldn't name that, we wouldn't name the cycloalkane as the parent chain. So let's go ahead and name that while we're at it. Okay, so this is 1, 2, 3, 4. That means that it's a butane. So there's the parent chain as well as the suffix there, and then at the 1 position we have a cyclopropane. Okay, so it's 1 cyclo. Well, I definitely didn't give myself enough room there. So it's 1 cyclopropyl butane. Okay, and so remember, since it is a substituent, it does end with a YL, and it is 1 cyclopropyl. So let me actually just write that in blue, so that way it matches the structure above. I like when it matches. It's gorgeous. It's gorgy. All right, so let's move on to the real scenario where we actually have a cycloalkane being the parent chain. So let's say we had, let's see, how many do we want? Do we want this many? How many is that? Let's do this. Throw something, little something there, little something there. All right. So again, so now it's very clear in my opinion that we have 1, 2, 3, 4, 5, 6, 7 carbon chain being the longest, and that is contained in the ring. Okay, and so the rules again is we want to make sure that we give the lowest number assignment for all of these substituents. Okay, and so the cool thing about a ring is that we can always make sure that we have a substituent at least at 1, right? So let's say we started numbering here. 1, 2, 3, 4, 5, 6, 7. Okay, now what if we started here? 1, 2, 3, 4, 5, 6, 7. So let's just compare these first. Obviously they both have a substituent at 1, but then in blue we have another substituent at 2. But in red we don't have another substituent until the 3 position, right? And so I don't really like the red numbering, so I'm going to go ahead and delete those numbers. Okay, but there is another option here, at least another one that's kind of obvious. There could be a few other ones, but if we start numbering here in green, 1, 2, 3, 4, 5, 6, and 7. Okay, so what do we got here? We have 1 at the 1 position again, and then also at the 2 position. That's the same for blue, but in green we have another substituent at the 4 position, whereas the 3rd substituent isn't until the 6th carbon if we choose the blue labeling. So I would choose green, because what we want to do is give the lowest number assignment to all substituents. Okay, so let's try and name this bad boy. Since it is does contain 7 carbons, and it is a cycloalkane. Remember, when we're naming cycloalkanes, we put cyclo in front. It has a prefix, and now we just name it as we normally would. So the parent chain is 7, so that's hept, H-E-P-T. And it is an alkane, so we finish that off with A-N-E. Okay, so since that's a cycloheptane, that is the parent chain. Okay, so this is the parent. Okay, so as well as the suffix But now what we need to do is name the prefixes. And so this is what and where are the substituents. So let's see. The first one we have at the 1 position. I'll draw it in green because that's what it is up above. 1 is the methyl group. At the 2 position we have a 2-carbon substituent, and so that is eth. Being a substituent, it's an ethyl. At the 4 position we have a methyl again. Okay, and remember we're going to go ahead and combine these two to make a 1,4-dimethyl. Okay, so I'm going to cross these out, and we got a 1,4-dimethyl and a 2-ethyl to basically add in front of our cycloheptane, right? And so remember also that the D in di isn't used for alphabetizing the substituent. And so what we want to do is go with the 2-ethyl first because E comes before M. Okay, 2-ethyl, and then we got a 1,4-dimethyl. And see if I can fit this here. Cycloheptane. Okay, so 2-ethyl 1,4-dimethyl cycloheptane. Wow, that's a mouthful, but that's the name of this guy right here. So those are pretty much the rules for naming cycloalkanes as well as straight chain or branched alkanes. And so this for sure is going to take some practice, but it's not going to come right away, and I think it's important to remember these rules. But you'll always, no matter how, even if you memorize the rules, for example, you're still going to need to come across some structures that are going to stump you and force you to think about them. And so numbering assignments are actually really tricky sometimes, and you have to again practice that in order to get good at it. You can't just read the rule and then know how to do it. So that's where. All right. So you know what? While we're on the topic of practice, why don't we talk about practice? You guys want to talk about practice? Let's just do it. So basically, these problems are going to be give the IUPAC name, actually, or the structure. Okay. So I might give you an IUPAC name, and you'll have to give me the structure of it. Okay. So I encourage you to pause this video, try it on your own before I cruise through it, because I'm going to try and go through it as fast as possible, so that way we can get stuff done. You know what I mean? So we need to look for the longest chain. So this one's crazy. This is like a really hard one, I think. I haven't even tried it yet, so hopefully I don't make a mistake as I go through these fast, but we'll see. Let me know if I do. Let's see. My eyeball tells me that it's probably 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, or maybe 1, 2, 3, 4, 5. Wait, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so the blue is not good, but what about this other one? We'll try. I don't have another one. Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we actually have 2 10s. That is the black and the red. And so what we need to do is take a look to see which one has more branch points. So over in this region, I guess the black and the red are pretty much the same, except the red will have more branch points if we're looking at this point right here. Okay, so we'll have a branch point here and a branch point here, whereas the black would only have this branch point right here. Okay, So I know that's a little confusing, but again, the red is going to have more branch points, so you want to choose the red in this case. And so that's, I'm going to hopefully try and delete these other colors here just to make things a little bit more clear for myself so I don't mess you guys up. But now we want to number it, and remember we want to number it according to, basically to give the first substituent the lowest number. That means we're going to number from here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Ooh. Yeah, that works. That works, that works, that works. Okay, so that is actually 10. So that is decane. So there's our parent, dec, and ane is our suffix. And now what we want to do is kind of tally up those methyls, those ethyls, and that sec butyl there. And so remember, this is going to be a 5-sec butyl, but it's under, and when we're alphabetizing, it's under B. This is a 7-methyl. This is a 3-ethyl, and this is a 2-methyl. Okay, so I'm just going to go ahead and see if I can just jump straight to the final name. All right, so B comes first, so that would be 5-sec butyl. And E comes before M, so that's a 3-ethyl, 2,7 dimethyl. Okay, decane. All right, so hopefully that's right. The only way that could be wrong is if I missed the longest chain in there, and I don't believe I did, but if I did, of course, just reach out to me and correct me. I can throw out another video to correct that, but that's basically the thought process. I'm going through these cold, that way you can kind of see my thought process live and how I might approach these problems, just to give you a better idea of how, not how you should do it, but how other people do it, because maybe you have a different approach, and that approach can be great, and you can come to the right conclusion also. Okay, so it's helpful to see how other people think. All right. Now, this one's a little bit more, not more difficult, but just different, because we have to be able to figure out the actual three-dimensional structure. And so I'll draw this carbon first, because it looks like he's got a lot of methyls on it. So methyl, 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 and then there's a CH2, and then there's another carbon with a hydrogen, and then that on that carbon is also 2 ethyl groups. So, okay, these are CH2, CH3, CH2, CH3. These are CH3s. Okay, now what we want to do is look for our longest chain. So, since these are both the same group, we could actually decrease the confusion, I guess, or remove any confusion. And it doesn't matter which carbon we start with. So let's do 1, 2, 3, 4, 5, 6. Same thing with these. These are all the same group, and so it doesn't matter where we finish. We'll end up with the same thing. And so 6 carbons should be the longest, and that gives us a hexane. Okay, hex being 6, ane being an alkane. And then that means we have to number our substituents, or our carbons first, and then our substituents. So remember, we want to number so that we, such that we give the lowest number to the first branch point. If it's equivalent, then you want to look at the second branch point, and otherwise you can go by alphabetical order. Okay, so this carbon should be number 1, 2, 3, 4, 5. Oh, I'm tripping. 1, 2, 3, 4, 5. Let's do, sorry, this is the first carbon. 1, 2, 3, 4, 5, 6, and that gives us 6. On 2, we have a 2, 2 dimethyl, and then on the 4 position, we have an ethyl. All right, and so that means we need to switch these, and so we'll get a 4. Oh man, messing up. 4 ethyl, 2 dimethyl hexane. All right, so let's move on to these ones. These ones are pretty chill, I think. Cycloalkanes can get complicated, but these examples aren't too crazy. Remember the cycloalkane. If you're going to call it a cycloalkane as the parent chain, then it needs to be longer than any other straight chain or other alkane that's coming off of it. And so in this case, this is 6 versus 1 and 1. That's definitely a cyclohexane. And since we have the luxury of giving it the lowest number possible, we will basically give it a 1,1 dimethyl cyclohexane. This is all one word. I'm just kind of putting it in 2 lines so that I can fit it on this this here whiteboard, quote unquote whiteboard. Now there's 6 carbons in that ring, and there's 1, 2, 3, 4 in that, so it is indeed a cyclohexane. So I'll go ahead and write that, cyclohexane. We also have 4 here, so this is a propyl, a butyl, and this is a methyl. Now we need to figure out how we want to number it. Well, if we number this 1 and this 4, then the butyl gets the methyl. Butyl gets number 1 and methyl gets number 4. But if we do the other way, where the methyl is 1 and the butyl is 4, then it's kind of assigning a substituent the same values, right? And so which one do we go with? Basically, if they're the same, we want to go and choose alphabetical order as our priority. So basically 1 is butyl because B comes before M. Okay, so it's a 1 butyl. Yeah, we're going to have to move that. Get out of here. 1 butyl, 4 methyl, and that's a cyclohexane at the end. 1 butyl, 4 methyl cyclohexane. Cool, that works. All right, so this one right here is a cyclo. It has a ring structure in it, and that's 3 carbons, whereas this one is 1, 2, 3, 4, 5 carbons, and so this is actually the parent chain, and having 5, it is a pentane. Okay, so this is actually a substituent, which means we need to name that cycloalkane and then change the ending not to an ane but to an L, YL. And so that is a cyclopropylpentane. All right, and so this one right here has 3 carbons in it. That's a ring structure compared to the 1 and the 1. So yay, we get a cyclopropane. Shimmer down, propane. Okay, and so since it's got 2 methyls on here, we can name this one 1 or this one 1. It does not matter, but the other does have to be a 2. We don't want to call this 2. And then therefore the other substituent 3, we want to give the lowest numbers possible to those. And so that would be a 1, 2 dimethyl. Okay, and here we go. Last one. This one's crazy. We're going from a name to the structure, and it's wild. So the way you approach this is basically look at the last thing, because that's going to tell you the meat of the structure, in my opinion. It tells you the skeleton, and it's a cycloheptane, which is cool because those are super hard to draw. So I like to start off with like a normal almost like I'm drawing a hexagon, but then bring it down And then there you go. And then it's like top is hexagon and the bottom is an octagon, if that makes sense. Obviously, the bond angles are going to be a little off in lengths or whatever, but it's all good. That looks pretty, I think. So cycloheptane. Now, what we want to do is kind of look at what our substituents are. Well, that's cool. It's 1, 1, 2, 3, 4 pentamethyl, so they're all methyls. But what you want to do is basically assign any carbon you want as 1. So I like this one as 1. And it says I have a 1, 1 methyl, so it's 1, 1. And then I like this one as 2, so I'll put a methyl there. I like this one as 3, well, because it has to now. And then this one is 4. And so there you go, 1, 1, 2, 3, 4 pentamethyl cycloheptane. And that is that. Hopefully these examples help you. But let me know if you have any questions. Okay, so I'll leave you with a little joke here. First of all, what's the most musical instrument on your body? It's the nose, because you could pick it and blow it. Bah. Okay, so that leads me into this next one. So why can't, I mean, there's obviously lots of varieties of noses, but why can't a nose be 12 inches long? Because then it would be a foot. I cracked myself up. I'm sorry. This is funny. I like this. I hope you guys are enjoying it. Bye.